All right, so in the last video, we talked about what a polynomial was and the difference between like monomial, binomial, trinomial, and we talked about like the degree of a function and standard form. In this video, we're going to talk specifically how to multiply two polynomials together. We did adding and subtracting polynomials in the last video. We're going to be multiplying in this one. Division is actually a little more complicated than all the rest, and that comes in later math courses. So we're not going to worry about that for now. We're just going to look at multiplying polynomials. We'll look at different kind of levels of difficulty. So the first level is what happens when you take like a basic monomial and you multiply it by a binomial. So we're taking something that has like one piece and we're multiplying by something that has two pieces. So something that would look like this: 2x times 3x plus 1. Now, this is something we've done before. Essentially, it's just like a single distribution. That's all it realistically is. Okay, so let's write that down. Single distribution. So all we're doing is we're going to take that first monomial, the one-term chunk, and we're going to distribute it to everything inside the parentheses. It has two chunks, which is why it's called a binomial. So 2x times 3x squared and 2x times 1. Okay? This is why you had to be comfortable with how to multiply and combine exponents, because it comes in handy with these questions. So for the first one, 2x times 3x, well, 2 times 3 gives you 6. And x times x, remember the rule is when you multiply, you add the powers together. So technically it's x power of 1 and x power of 1. So when you multiply them together, you get x power of 2. And then the second one, when you distribute the 2x times 1, well, anything times 1 is just itself. So it's just 2x. And that's it. That's all it is for a monomial times a binomial. It's just a single distribution, and most of the time you don't have to combine anything. Okay? Now what happens if we take that and we step it up one notch? And what happens if we do a binomial times another binomial? So in other words, we're taking two things that each have two pieces, and we're multiplying those together. Okay, so let me scroll down a little bit. So something that would look like this: 3x plus 2 times 5x minus 3. Okay, and essentially this is only a little slightly different than the previous question. The previous question, we wrote down that it was a single distribution. Here, it's technically just a double distribution. Okay, so let's write that down. Double distribution. Or sometimes a lot of teachers will refer to this as the FOIL method. I usually don't refer to it as FOIL just because like students will remember the term FOIL, but they don't remember what it stands for. It stands for first, outer, inner, last, which can help you if you remember it, but otherwise it's a little bit tricky. So the idea behind a double distribution is you start off with the first piece, so that 3x squared, and you multiply it to both pieces in the other binomial. Okay, but notice I didn't multiply by that too. Okay, so it multiplies to both pieces on the other side. Then you do a second distribution. You multiply this 2 also to both pieces in the other binomial. Okay, and then at the end you'll have to do some combined like terms, but let's do one step at a time. So let's do the purple one. So the first one, 3x times 5x. Well, 3 times 5 is 15. X times x gives you x squared. Then for the second one, 3x times negative 3. Well, positive times negative is negative, and 3 times 3 is 9, so 9x. Okay, so that's the first two. That's the first distribution. Then for the second distribution, for that 2, well, 2 times 5x, 2 times 5 is 10, so plus 10x. And then 2 times negative 3 is negative 6. Now, if you leave it like this, it would be incorrect because there are things you are allowed to combine. We do have like terms here. Okay, so we do have to combine like terms. Now, in this specific example, there's no other x squared, so we can write that, bring that down. Okay, but there are two terms that have x's in them, so we can combine these. Okay, so negative 9x plus 10x gives you positive 1x, so plus x. And then the number's by itself, so we can put that on the end, minus 6. That would be a complete answer because we can't combine any of those three pieces. And just to review the last section, the name you would call this, it's a second degree, because the highest power is 2, and it's a trinomial. So it's a second degree trinomial. Okay. Now what happens if we take this and we go one step even further? And this is about as difficult as they'll get for now. Okay, so in other words, what happens if we take a binomial and we multiply it by a trinomial? Okay, so again, this is about as difficult as it'll get for now. Let's scroll down one more time. Okay, so what if it looks like this? X plus 5, that's the binomial, times x squared minus 3x minus 2. Okay, so it's a 2-term polynomial times a 3-term polynomial. Okay, now this is still going to be a double distribution. And I'll show you. Okay, so we're still going to take that first term in the binomial, that x, but we have to multiply it to every single thing in that other group of parentheses. So we have to multiply it here, here, and all the way down here. So it's still technically a double distribution, it's just longer. So first one, x times x squared. Remember, there's always that invisible 1 right there. So 1 and 2 make the rules, add them together. So we get x power of 3. Okay, second one, x times negative 3x gives us negative 3x squared. And then the last one, x times negative 2, negative 2x. Okay, and then the second distribution, multiplying the 5, again you multiply it to every single piece in that other parentheses. Okay, so 5 times x squared is 5x squared. 5 times negative 3x, negative 15x. And then last but not least, positive 5 times negative 2, negative 10. And then again, we have to go through and combine like terms. And this one's slightly different because there's different things we can combine here. So we'll start off with the highest power. The highest degree here is 3. And there's only one term that has power of 3. So let's write that down, x power of 3. Okay, now for the x squareds, I have negative 3 right here, and I have a positive 5 right here. So those can combine. Negative 3 plus 5, we get plus 2x squareds. And then we go down the line. After x squareds goes x's. Okay, so I have negative 2x right here, and negative 15x right here. Again, if you're messing up with the negatives, use a calculator. So negative 2x minus 15x, negative 17x. Okay, and then numbers always go last, and then numbers by itself. There's no other numbers on there, so minus 10. And that's it. Okay, so even though it's a binomial times a trinomial, it's still a double distribution. It's just a longer question. Okay, now we're not going to do one, but if it was a trinomial times a trinomial, that would be a triple distribution. That gets even more complicated. Okay, but for now, this is as complicated as it's going to get, and we'll be practicing this next couple days as well.